we are looking at simplifying square roots, and there's a couple different methods for this that I'm going to show you. The thing at the top there is to help you remember the easy way to do this. So it says, always put your socks in matching pairs and keep the leftovers in the dresser. So the analogy with this is when you have your socks and you do your laundry, you take the socks that match up and you bundle them into little pairs. And then whatever that leftover sock, the one that you can't find the match for, that just kind of gets stuck in the back of the dresser there. So this is kind of to help you remember how we're going to do this. So the sock method here that I'm talking about is we're going to make a factor tree for each of these to simplify these. So a factor tree means break it down into a prime factorization. So what two numbers multiplied equal 45? So we would have 5 and 9, and then 9 would break into 3 and 3. So what I mean by my sock pairs is here is a pair of socks, and here is the leftover sock that didn't have a pair. It got lost in the washer, whatever. So the pair can come out in the front, and the leftover sock has to stay in the dresser there. So 3 root 5 is the simplified version of square root of 45. So they're simplified when they don't have any square root factors left. So this is the easy way to do it, is to make the factor tree. If you're really good at your math facts, you know all of your math facts and all your perfect squares, there's a quicker way to do it. So the quick way is you know the perfect square factors of 45. So you would break this into 9 and 5, and then the square root of 9 is 3, and the square root of 5 stays under the root there. So that's two different ways to do it. I'm most likely going to show the sock method most of the time because in my experience that works best for kids. Okay, so let's try example 2 here. So if I do the factor tree, this would be 2 and 12, 2 and 6, 2 and 3. Alright, so now I'm going to pair things up. So I have one pair here, and then these are both leftovers. You could think of this as like a blue sock and a white sock. You're not going to pair those together. So those are two leftovers. So my pair that I made comes on the outside, and the other two stay on the inside. So, and they need to multiply there. So this is going to become 2 root 6. So 2 root 6 is the simplified version of square root of 24. Okay, now if you were to do the quick method, you would look at this and say, okay, well, 24 breaks into 6 times 4, and 4 is a perfect square, so that becomes 2 root 6. Okay, a few more here. Example 3, square root of 100. So before you start to break this down, hopefully you recognize that 100 is a perfect square, and we can just say, oh, that's 10. Square root of 100 is 10. If you don't recognize that, you can break it all apart, and you're just going to have a bunch of numbers that get multiplied together to make 10 for you. So 96 on the next one. So I always divide them by 2 if they're divisible by 2. It just kind of, I don't know, that makes sense to me. It's an easy one to look at. So this would be 2 and 48. And then that's 2 and 24. And then 2 and 12. 2 and 6. 2 and 3. Now I'm going to make my pairs. So I have, here's a pair, and these are both left over. So I have 2 pairs that are going to multiply together on the outside, and 2 numbers that are going to multiply together on the inside. So this would become 4 root 6. Okay, and then the last one, square root of 10. If I try to break 10 apart, I end up with 2 and 5. And so I don't have any pairs at all, so that means there's nothing I can do to simplify this. Can't simplify. Alright, so you try the last two.